All right, we're on question 3 for worksheet for 2.4. It says there's a group who requested for volunteers to rake leaves. We're going to represent that with the set R, and or wash windows, which we're going to represent with the set W. So the students who will rake leaves fit in set R, and the students who wash windows will be in W. So when we're taking a look at this, then it says the group will give each person who volunteers a free t-shirt. They asked 50 total students. Of the students asked, 38 volunteered to rake leaves and 21 volunteered to wash windows. 18 volunteered to do both. We want to ask, how many t-shirts does the group need to buy to give out? So notice the same idea, right, where if I'm trying to think about how many total students I need, I obviously can't just add all those together, right? 38 and 21 and 18 is more than 50, right? It's more than the total number of students that they asked. So obviously we need to try and use our things that we've been learning about how to count the number of elements in sets in order to find our answer. Now, one of the first things that we need to do is figure out what in terms of sets is it that we're actually trying to find, right? If we're actually looking for how many t-shirts, we're really asking how many total volunteers which would be the people in R or W, right? The people who either rake leaves or wash windows, which does include both, but we're putting those together. So really notice what that is. Remember, if you're in one or the other, then you're really in the union. So we're really looking for R union W. Now there's two different ways that we could solve this problem. So either way you do it is fine. We could do one way where we could use the formula. Or another way to do it is to use a Venn diagram. And really, it just kind of depends on both what your preference is, which of the two you prefer to look at, and which one seems easier for this particular problem. Like in problem 2 that we just did, the Venn diagram would have been tricky to find because we were looking for the intersection. And normally when we fill in Venn diagrams, we start with the intersection. So that one would have been a little tricky to do. So let's try and look at the formula way first. So remember, if we're trying to look for the number in the union, so the number in our union W, well then we take the number in each, so the number in R plus the number in W, but then by adding those together, remember we've counted too many people. We've counted some people multiple times. So we need to subtract the people we counted twice, which is the number in R intersect W. Remember, this is like the idea of the number in either is the number in each minus the number in both. So we have to think about what those are. Well, what's the number in R? Well, that's the number of people who rake leaves. So from up top, we can see that that's 38. There are 38 total people who rake leaves. The number of people who wash windows, we see that there was a total of 21 people who wash windows. And then we have to subtract off from those people, there's a bunch of them that we counted 2 different times. We counted them for raking leaves and washing windows separately, even though they're really the same person. So we subtract off the number who did both. And when we look up top, we see 18 volunteered to do both. So that intersection number is 18. So then we need to add up this total. So if we take a look, we can get our handy dandy calculator. Let's see if I can move that in your screen for you. So we've got 38 and 21, and then we need to subtract off 18. Notice, even just with 38 and 21, 59 was more people than they asked to volunteer, so it's already too big of a number. So then we subtract the 18 and we find 41 is the total. So that's the total number of volunteers. So that means that they need to buy 41 shirts. So this is one way to do the problem. We could have finished the problem and been done now if that was the preference that we have. I just want to show you another way to do the problem. So instead, we could have tried to do the problem with a Venn diagram. So we'd draw a Venn diagram, and we'd notice, all right, well, I've got two different groups of people here. I've got leaf rakers and window washers, so R and W. And we need to fill in this Venn diagram. So remember, with this technique, what we're doing is we're filling in the diagram, and we're trying to do it so that when we count regions, we have unique people in each region. So then we can add up the unique groups of people, so we don't have to do the subtraction on the outside. We're just going to do some subtractions along the way of filling out the diagram. So remember, to fill out the diagram, we start in the middle. So we start in this overlap, the people who did both raking leaves and washing windows, which we saw before. The number in the intersection, the number who did both, was 18. So we're going to put an 18 right here in the middle. So now let's focus on the rest of R. Notice in total for R, we had 38 people. But remember what we've talked about, we've already counted a bunch of those people. So what we need to do to figure out what goes in this region is take away the number that we've already counted, because what we want is we want the total of all of the parts of circle R to add up to 38. So if I take away the 18 from 38, I'm only left with 20. And what those people represent, those 20 people, are the people who only raked leaves. So they only volunteered for that task and not washing windows. So notice 20 and 18 together make the total of 38. Now shifting over to looking at the people who wash windows, we can see that we've got a total of 21 people. But notice we've already counted 18 of them, because those 18 did both. They washed windows and raked leaves. So if we take away 18 from 21, we're only left with 3 people. So there were 3 people who only washed windows. So they just washed windows and didn't rake leaves. But notice together the 3 and the 18 makes the total of 21 for all of the people who washed windows. So now what we can do is we can take a look at each of these groups then, the 20 and the 18 and the 3 are all distinct groups of people. They're all unique people. So if I'm counting them, I'm only counting each person once. So we can take that 20 plus the 18 plus the 3. We're counting up all of these people. And notice again, 20 and 18 is 38 plus 3 is another 41. We end up with the same total in the end. They need to buy 41 shirts. So this time where that subtraction showed up was in filling out the Venn diagram, right? We had to subtract while filling it out in order to get those distinct groups of people that then we could add together. So either way you do the problem is perfectly fine. Like I said, it just depends on what your preference is, what you like better, and really just based on the problem, which one you see first, which one seems easier to do in this context.